You all to the Spark Research YouTube channel. This is Dr. Veer Chandra, Assistant Professor in the Department of ECE, SRM, Institute of Science and Technology. In this session, we are going to talk about the electromagnetic theory and interference related questions and answers which has already been asked in GATE 2022. Okay, so before going ahead, here is the uh, detail about my primary institute, that is SRMIST. You can see here it has ranked on 14th as per the NIRF 2025, just about to the IIT ISM Dhanbad. Okay, so why are we talking about this particular EMT theory course? Because this is very, the easy subjects, and it can be your the ranking subjects, because the mostly the questions come in the 6 to 11 marks. Then what are the major topics? You can see here, these are the major topics: electrostatics, then Maxwell equation, wave propagation, transmission line, and waveguides. So these are the major topics. And if you wanted to talk about all these topics, I have already discussed in the different videos. You can check it in the description as well. Okay, so let's go ahead. So primarily this GATE 2022 has been conducted by the IIT Kharagpur. Here is the question. Question number 52. It's related to the waveguide theory related questions. What is the question? So question is, your waveguide consists of two infinite parallel plates at a separation of 10 raised to the power minus 4 centimeter with air as a dielectric. Assume the speed of light is given here, and now what do you have to find? You have to find the frequencies of TM wave which can propagate in this waveguide. So question is actually, you in this question waveguide has given the information about the waveguide. Actually the separation is given here, and now it has asked that what which wavelength or which frequency will propagate through this waveguide, right? So we have to check whether this frequency will pass or not, which this frequency will pass, or this, all this frequency will propagate through this waveguide or not. So how can we find out? So very easy. We have to find out the first cutoff frequency. Means if once we'll find out which minimum frequency will pass, once we will find, then it if like if it is greater than that, then in that case this frequency will pass. And if these frequencies are lesser than the cutoff frequency, in that case frequency will not propagate through this waveguide. Okay, as per answer key provided by the Kharagpur, your answer should be your A and C both only. Okay, let's go. So here you can see, suppose this is your waveguide, and which is carry the some your signal. So here these type of, actually now how can we find out the cutoff frequency if some rectangular wave? Actually this is the example of the rectangular waveguide as well. So how can we find out the cutoff frequency? So this is the most important formula that you can remember. This is valid for rectangular waveguide. So omega is your angular frequency, that is twice pi f, is equal to 1 over square root of mu e. Mu is your permittivity and E is your permittivity for your medium. The square root of m pi by a whole square. M is your any integer number, maybe 0, 1, 2, 3 onwards, and A is the dimension, and n pi by b, A and B both are the dimension of the rectangular waveguide. Okay, so so this is the formula, but in this case, actually in this particular question it has been given that the TM mode only we are going to find. So for TM mode, your n may be 0, but m cannot be 0. M is basically representing the vertical one, so it should not be 0. So minimum it should be 1. So let's put the n is equal to 0. So if you will put the n is equal to 0, this part will vanish, and here 1 over a square root of mu, and these parts m pi by a is remaining. So here is your m pi by a, and pi and pi will be cancelled out. Omega is equal to, also you can write 1 by twice pi f, right? So omega is equal to twice pi f, so f is equal to 1 by twice pi, and this one, so 2 and pi will cancel out. Finally, the this formula can be used to find out the cutoff frequency in this case. So f cutoff is equal to mc by 2a. C is nothing, a speed of light. C is equal to 1 over square root of this, that is square root of mu e, right? So let's find out the cutoff frequency. So these things has given, the plate separation is given and the speed of light is given in our question, and so formula we are going to use it, this to find out the cutoff wave, cutoff frequency. And also we can also put the m is equal to 1 2 3 4, all these like for different mode. So for fundamental mode m is equal to 1, for other higher mode like tm1 tm2 tm3 like that, 102030 like that. So these are m is equal to 2 3, all are related to the higher order mode of your transverse magnetic mode. So for the time being we are going to use this formula mc by 2e, because we are considering the only fundamental mode. This is your speed of light. Okay, so use this formula to find out, right? So fc is equal to, put the values, m is equal to, we are going to use a1 for fundamental mode, and c is already, you know, the speed of light, and d is given, so put this, you will get the value of 1.5 into 10 to the power 14. So in our options, now you can check, first option is higher than this cutoff frequency, so definitely it will propagate. Second option, this is lesser, so it will not propagate. Third, it is higher, so it will propagate. Fourth, this is lesser, so it won't propagate. Finally, your option A and C, both frequency will propagate. Okay, so let's go ahead. We can have another questions. So question number 65, you can see. Now in this question, in an electrostatic field, the electric displacement density vector, that is D, is given. What, right? So here electric displacement density is given, not electric field. So D is equal to E into you know, the epsilon. So this is not electric field but related, right? So here the electric displacement density is given. I, J, K are the unit vectors along x, y, z axis. Now consider a cubical region R. There is some cubical region R centered at the origin, having the length of 1 meter. Vertices are given like this, plus minus 0.5. Now you have to find out the electric charge enclosed within that R, right? So how can we find out? So as per your answer key provided, your answer should be lies in this range, and means 0.48 to 0.52. Okay, so here you can see this is your cubical region, and your electric dense displacement is given, D is equal to this one, and now you have to find out the electric charge. So how can we find? So major thing is that first, in order to find out the total charge, that is Q, you have to find out the charge density, that is rho. So how we'll find out the charge density rho? So rho, you can find out divergence of D with the help of the divergence of D. So once we'll get the charge density, that is rho, after that it is very easy to calculate the total charge, because you can integrate, right? Rho into dV, then you can get. So we are going to use this formula, and finally your answer is 0.5, right? So let's see how let's see the steps how to find out. So first, use a Gaussian law. This is your divergence of D. This will give you the charge density, right? So once we'll get the charge density, then the second and the final step is like just integrate it over rho v, that is rho v into dv. So charge density into dv. So this is the final step, right? So step number one, get the charge density using this formula, divergence of the D, then integrate rho into dV, and then get the final Q. That is the very simple steps, only two steps, right? So first let's get the rho V. So in order to get the rho V, that is charge density, just use this divergence technique, divergence of D, that is your, this is a scalar divergence, a scalar quantity. So just differentiate it, dx by dz by dz, dy by dy, and get. So this is your charge density, right? So 3x square plus 3y square as per the questions already given. So dz by dz, dx square, this part will be the 0. You can check it, okay? So once we got the row b, that is the this step over, first step over. Now this is the row b, means the charge density. Now we'll put it here and we'll integrate over the volume. So what is our volume? In our question itself, it is given that the volume is of cubical type, right? So plus minus 0.5 to 0.5 in x, y, z in all direction, right? So dv is equal to what? Dx into dy into dz. And what is rho v? Rho v is this one, 3x square plus 3y square. Now just integrate it and nothing else. So for integration, these are the steps. You can see z will be the one, integrate it first of all with respect to dx, then again the dy, and finally you will get the value of 0.5, that is q. So from here onwards nothing is there except the integration. So first divergence, second integration, finally your charge is 0.5. Thank you for listening. That's all in this session. In upcoming sessions, I am also planning to bring some another subjects. Please drop your comments. What are the major subjects you are looking for? Okay, so thank you. Keep on sharing. Thank you.